In this video, not only will we learn how to convert from a rectangular to a polar coordinate, but I'll also show you what sets apart arctangent in determining theta for each of the 4 quadrants. So in the description, I'll leave a link to my website. This is just a snippet of my lesson. So the full lesson includes introduction to polar and rectangular coordinates. There's homework assignments, notes, answer keys. Stay till the end. I'll talk more about that, but let's jump right in. So let's take a look at a quadrant 1 rectangular coordinate 2, 3, which is seen over here in this rectangular coordinate system. So R is the simplest one to do. It's just remembering the formula. So that's the square root of x squared plus y squared. But where does that come from? It comes from the Pythagorean theorem. So if we look at the picture here, right, here's the radius. And if we create this right triangle here, right? Here's my right angle. So we travel 2 units to the right and 3 units up. Now, if you do the Pythagorean theorem, right? 2 squared plus 3 squared, and then take the square root. So it makes perfect sense. You would get the square root of 13, right? So, or we can look over here. So that's square root of 2 squared plus 3 squared. 2 squared is 4. 3 squared is 9. 9 plus 4 is 13, so the square root of 13 would be R, right? So that's the simplest one. So it's really determining what theta is. Now, you might have already in class learned that you're going to use the arctangent. We're going to discover why that's true, right? So theta is going to always be the reference angle. And if you remember what is a reference angle, just make sure that one of the sides of the angle has to be the x-axis, right? So it would not be up here, again, because one of the sides of the angle has to be the x-axis. And so since we have a right triangle, we can certainly use SOHCAHTOA. Right, so SOHCAHTOA. Okay, so let's take a look at this diagram here, right? So again, here's theta. Here would be the opposite, O for opposite, A for adjacent, and the hypotenuse is always across from the 90-degree angle. And so the opposite side would be 3, and hypotenuse would be the square root of 13. So if you pop arc sine of 3 divided by square root of 13 on your calculator, it would give you the angle. So that would give you 56.3 degrees. Now, is 56.3 degrees a quadrant 1 angle? Well, yes, it is, right? So if you remember, here's 0 degrees. We travel, the positive angles is going to be counterclockwise. So here would be 90 degrees, right? Here would be 180, 270, and then it loops back around at 360. So 56.3 degrees is between 0 and 90. That would actually be the correct answer. Okay, so let's do the arc cosine. So that would be the adjacent, which is 2, divided by the hypotenuse, which is square root of 13. So if you do the arc cosine of that ratio, surprise, surprise, you would also get the same answer. So you could technically use arc cosine as well. Arctangent, if we remember, right, so if you just look at the ordered pair, so that would be always the y value of the coordinate divided by the x value of the coordinate. So that would be 3 divided by 2, or if we look at the picture, right? So that would be opposite side, which is 3, divided by the adjacent side, which is 2. So that does definitely check out. And then again, surprise, surprise, that would give us the exact same answer. So all 3 of them produce 56.3 degrees. So if you ever get a quadrant 1 rectangular coordinate, could you use all of the, right, arc sine, arc cosine, or arctangent? Absolutely. Okay, but you're going to see why did we just pick the arctangent? So again, we'll see that in a second. Okay, so let's take a look at a quadrant 2 angle, right? So here is 3, -4. So again, R is the easiest one. So that would be the square root of 3 squared, which is 9, plus the square, plus -4 squared. -4 times -4 is positive 16. 9 plus 16 is 25. And so the square root of 25 would be 5, right? So the radius is 5. So again, over here on the unit circle, right? So this is what we just found out. So we went over 3 units to the right and 4 units down. So that would be -4. Here's my right angle. So again, my reference angle would be over here. So if you did the Pythagorean theorem, we would get the same answer. So that would be, just trying to keep the same color here, right? So that would be, the radius is 5. So again, just like before, let's actually use SOHCAHTOA, and we'll compare all of the 3 inverse trig functions, right? So here would be the opposite side over opposite, A for adjacent, and here it would be H, which is the hypotenuse. It's always across from the 90-degree angle. Okay, so let's take a look what's going on here. So actually, I should have labeled it in this diagram here. Okay, so the sine, remember, it would be opposite over hypotenuse. So that would be -4 over 5. The arc cosine, right, would involve the adjacent over hypotenuse ratio. So that would be 3 over 5. And then tangent would be opposite over adjacent. So in this case, it would be -4 over 3. So if you would put all of those into the calculator, you end up with the arc sine as -53.1 degrees. Now, is that a quadrant 4 angle? Yes, it is. So remember, negative angles travels clockwise. So if this would be 0 degrees, here would be -90 degrees, right? Here's -180 degrees, so on and so forth. So -53.1 degrees is between 0 and -90. So that would actually work out. If we did the arc cosine, it would be +53.1 degrees. And we'll actually talk about why this makes sense. Okay, but wait a minute, 53.1 degrees, that's in quadrant 1. Uh-oh, so we can't do that, right? 53 is between 0 and +90 degrees, so that's not going to work. And then if we did the arctangent, we would also get the -53.1 degrees, and that would be in quadrant 4. So technically speaking, if you have a quadrant 4 rectangular coordinate, you could actually use the arc sine as well. But again, why do we only focus on the arctan? It's just in math, we like to remember things easily. So we'll see that in a second. But again, if you have a quadrant 4 rectangular coordinate, you can absolutely use either. So actually the final answer here would be R, which is 5. And theta, we found out, was -53.1 degrees, right? So R comma theta, so that would be our final answer. Okay, so really quickly, why did we get arc cosine to be +53.1 degrees? And why did the arc sine and arc tangent give us the negative? So I'll leave a link in the description if you want a refresher of the inverse functions lesson. So again, I'll leave that in the description. But pretty much in that video, we talked about the range restriction for the inverse function. So if we remembered, arc cosine was between 0 and pi radians, or 180 degrees. So that makes sense, right? So those are quadrants 1 and 2 angles whenever we do arc cosine. So that makes sense why we got +53 degrees. Arc sine, that was between -90 degrees and +90 degrees, right? -pi/2 and +pi/2. So that's why it gave us a quadrants 1 and 4 angle, or -53 degrees, right? That was in quadrant 4. That works out. Arctangent is very similar to the arc sine, but I'll put parentheses just because you can't actually include those endpoints because it would be undefined there. Okay, but anyway, this was just a side note. So that is why the arc sine and arctangent, that's why it gave us the correct answer for this quadrant 4 rectangular coordinate. Okay, so in a nutshell, technically speaking, you could do step 2 first and step 1 first, but so to convert from a rectangular coordinate, x comma y, to a polar coordinate, r comma theta, so I put this in step 1, but the very first step is you have to determine where that rectangular coordinate is, what quadrant it's in, because that determines which formula for theta you're going to use, okay? And we already talked about the radius would be that formula here, and again, that comes from the Pythagorean theorem, okay? So so far we did quadrants 1 and 4, so you might have already learned in class that you're just going to be using the arctangent So remember arctangent, that would be the y value of the coordinate divided by the x value of the coordinate. This over here just means that the denominator can't be 0 because it's undefined. Okay, so next we're going to take a look at what would be the formula for theta for quadrants 2 and 3. And then we're going to look at, well, what if the rectangular coordinate is actually on the quadrant? That's called, so what would be the quadrantal angle there? Okay, so let's take a look at, so this would be -610, so that's going to be a quadrant 2 angle. So you might have already learned in class, you're going to do the arctan plus pi radians or 180 degrees. So we'll see why that is true. Okay, so since we're going to do SOHCAHTOA here, if we actually sketched this quadrant 2 angle here, right? So we went 6 units to the left, 10 units up. If we did the Pythagorean theorem, to figure out r, or you could use that formula. So that's the square root of x squared, or -6 squared, which is 36, plus the y squared, or 10 squared, which is 100 degrees. So 36 plus 100 would give me the square root of 136, right? So that's going to give us the hypotenuse. Okay, so let us label. So this is the hypotenuse. Theta, again, is my reference angle, so that's over there. So this would be adjacent, and here would be the opposite. Okay, so if we did SOHCAHTOA, the sine ratio would be opposite, which is 10, over the hypotenuse, which is 136. So if we did arcsine, we'd get the angle, and so we would end up, if you put that on your calculator, to positive 59 degrees. If we did arc cosine, that's adjacent, or -6 divided by the hypotenuse. If you put the arc cosine of that ratio, you'd end up with 121 degrees. And then the arctan would be opposite over adjacent. Pop that in our calculator. That ratio, arctan of that ratio would give us -59 degrees. Okay, so what is going on here? So 59 degrees is in quadrant 1, up, but we're in quadrant 2, so that can't be. Arc cosine would give us 121 degrees, right? So that's between 90 and 180. That's quadrant 2. So that would actually work. And then arctangent, -59 degrees, that's actually in quadrant 4. So that's not going to work. So actually, when we have a quadrant 2 rectangular coordinate, you could totally use the arc cosine, right? That's going to give you the correct answer. But again, in class, you might have learned already that what we're going to do is the arctangent ratio, right? So in general, that's the y value of the coordinate divided by the x value of the coordinate plus pi radians, or 180 degrees, since we're in degrees here. So the arctan got us -59 degrees. Now, if we add 180 degrees, that would actually give us the correct angle. So we would get 121 degrees. Okay, so why would we do that? Why couldn't we just use our cosine? So again, in math, we just like to do things to remember stuff easily. So we're just going to try and involve arctangent with everything. So we could see we do get the same answer. Okay, and last but not least, let's take a look at -6, -1. So that would be in quadrant 3, right? So this is a quadrant 3 angle. So 6 units to the left, 1 unit down, totally not drawn to scale. So if we use the R formula, so that would be the square root of -6 squared, which is 36, plus the R squared. So -1 squared would give me 1. So this would be the square root of 37, or you could have technically done the Pythagorean theorem here. Across from the 98-degree angle is the hypotenuse, right? So theta is my reference angle here. So here's the opposite side and the adjacent side. Okay, so let's take a look if we did the inverse trigs for all of these, right? So again, we have opposite over hypotenuse for sine, so that's -1 divided by the square root of 37. Arc cosine is going to give me the adjacent, which is -6 over the hypotenuse. And then arctangent is going to be opposite, -1 divided by the adjacent. Okay, so if we put all of these on our calculator, Again, let's see what's going on. So here we'd get negative 9.5 degrees. Our cosine would give us 170.5 degrees. And 9.5 degrees would be for the arctangent. Okay, so again, this would make sense because of the restrictions, but anyway, negative 9.5 degrees, that is in quadrant 4. Oh, that wouldn't work because we're in quadrant 3. 170.5 degrees, that would be in quadrant 2. Oh, that's not going to work, right? We're in quadrant 3. And inverse tan would also not work, right? This would be in quadrant 1. So how in the world could we get, right? So a quadrant 3 angle would be between 180 degrees and 270 degrees. So again, in class, you might have already learned that similarly to the quadrant 2 rectangular coordinate, you're going to find the inverse tan plus pi radians, or 180 degrees. So let's see if this would give us a quadrant 3 angle. So if we remember the arctan, we got positive 9.5 degrees plus 180. And lo and behold, we end up getting 189.5 degrees. This is absolutely between 180 and 270. This is definitely a quadrant 3 angle. So there is our theta. Okay, so if we remember, we got the square root of 37, which is our r, and then theta was 189.5 degrees. So this would be my polar coordinate. Okay, so if we noticed, when we did the quadrants 2 and 3, what you do is you'd find the arctangent and then you would add pi radians or 180 degrees. Okay, and then if we used a quadrant 1 and 4 rectangular coordinate scenario, you would simply just find the arctangent. Okay, so again, we use the arctangent in all quadrants 1 and 4 rectangular coordinates, but in the quadrants 2 and 3, you would just have to do that extra step and add 180 degrees. Okay, so last but not least, what would you do for a rectangular coordinate that actually is on one of the quadrants? So if we took a look at 0, -8, that would be down here, right? Now, if you were to try and draw a right triangle, you can't. So actually, it turns out that theta is so easy when you are actually on a quadrant, right? This is not in quadrant 3 and it's not in quadrant 4. It's on this quadrant here, and we already know that this is 270 degrees. So we already found our theta in one step. So actually finding the r here would be the more tedious one here. So that's 0 squared, because that's x squared, plus the y squared. So that's -8 squared. So 0 squared is 0. -8 squared would be 64. 0 plus 64 is 64. And last but not least, the square root of 64 is 8. So our our polar coordinate would be 8, 270 degrees. Could we have also written down 8, -90 degrees? Yeah, that's the same polar coordinate because -90 and 270 are coterminal, right? So 270 degrees counterclockwise would be the same thing as going 90 degrees counterclockwise, right? We would put a negative. So either one of those would be fine. Now, is it a coincidence that our radius, which was 8, that number is same as, right? It doesn't matter. I'm not talking about the signs here, but the actual number, it's not a coincidence. So if you want to use that as a shortcut, it would always be that positive. Okay, so if you have a rectangular coordinate that's on a quadrant, you're going to find that angle by, you're just going to draw or sketch that ordered pair and just use the picture or the illustration to figure out where theta is. So that's actually the easiest one. So let's do one more quadrantal situation, right? 3, 0 is over here. And we know that this would be 0 degrees or, right, 360 degrees. So could you write the 0 or 360 for theta? Absolutely. Okay, so we just have to figure out the r, which is x squared here, or 9, 3 squared is 9, plus the 0 squared, which is 0, the square root of 9, so the radius would be 3. Again, it's not a coincidence that we get the same number here. So last but not least, we could put 3, 0 as our polar coordinate, or if you wanted to put 3, 360 degrees, right? So that's all the same. That's saying the same thing. So again, in the description, I left a link to my website. If you're interested, if you're a student learning this for the first time or a teacher, you're more than welcome to. I have here 43 lesson slides. It goes into the introduction of polar and rectangular coordinates, how to convert between them. There's homework assignments, there's answer keys, notes, all that fun stuff. So again, if you're interested, I'll leave that in the description.